Hello, my name is Daryl Shirley, and this is my Lab 4. Introduction. In this lab, I will be going over the purpose, main ideas, fundamental physics principles, system and surroundings, preview, experiment, glow script, model, possible errors, questions, and conclusion. Purpose. The purpose of this lab is to measure the magnetic field caused by a bar magnet and build a computational model to give a visual representation of the invisible magnetic field at multiple points around it. Main ideas. The main idea of this lab is to measure the magnetic field of a bar magnet using the physics equations we went over in class. Fundamental physics principles. The fundamental physics principles that we will be using in this lab are the magnetic field created from a dipole with a magnetic moment at an observation location. Or as we see, B equals mu naught over 4 pi times 1 over r cubed times 3 times the magnetic moment dot product r hat times r hat minus the magnetic moment. System and surroundings. The system of this lab experiment is the bar magnet. The surroundings of this lab experiment are the Earth's gravity, the Earth's magnetic field, the table the magnet is resting on, and the phone using the magnetometer. Preconditions. The preconditions for the lab coding were as follows: the magnetic constant K, 1 times 10 to the negative 7, the magnitude of the magnetic field of the Earth, and the distance of the observation location away from the bar magnet. Preview. The rest of the lab report will be going over the experiment and the data gained from it, the glow script code, glow script model, errors and possible explanations, the 2 what-if questions, and the conclusion. Experiment. To the right is a drawing of the physical experiment that was done in which a bar magnet was placed at the end of a meter stick and a phone was used to measure the magnetic field at specific distances away from the magnet. The statements that describe what I saw were: as the magnetometer moves closer to the magnet, the measured x component of the magnetic field increases. When the magnetometer is far away from the magnet, it measures a near zero magnetic field in the x direction. The data was then collected and placed in the Excel sheet to the right. Using the graph equation I got from the graph plotting ln of bx versus ln of r, I was able to calculate the magnetic moment. I set the equation, the magnitude of the magnetic field of the bar equals k constant times r to the n power equal to k constant times mu divided by r cubed. I got a value of 0.2 for the magnetic moment. Glow script code. As you can see to the right is a picture of my glow script code. In my code, I used the value I calculated for the magnetic moment to simulate the magnetic field of the magnet. I also implemented the equation of the magnetic field that I explained before. Glow script model. To the right is a picture of my glow script model. As you can see, it shows 7 different observation locations, 2 on the x-axis, 2 on the y-axis, 2 on the z-axis, and 1 at a 45-degree angle away. The magnetic field arrow shown emulates a magnetic dipole and accurately shows the magnetic field directions of the bar magnet. Errors and possible explanations. Possible errors that could have occurred during the experiment are incorrect distance measurements due to an uncalibrated phone with the magnetometer. And possible errors that could have occurred during the coding were an incorrect magnetic moment that could be caused by incorrect data and bad scaling for the magnetic field arrows where they might show incorrect magnitude. What if and what does it mean questions. What if I hadn't orientated my phone to compensate for magnetic north and had instead laid out my meter stick at some intermediate angle with respect to Earth's magnetic field? How would my results have changed? My results wouldn't have accurately measured the magnetic field and direction caused by the bar magnet, since I wouldn't have compensated for the non-negligible magnetic field caused by the Earth. What if I were to stick 2 identical magnets together end to end and run the experiment again? How would I expect my measurements to differ? I don't believe my measurements would differ due to the fact that double bar magnet would behave the same as a single bar magnet. Conclusion. In conclusion, during this lab, I measured the magnetic field of a bar magnet and calculated the magnetic moment. I then used that magnetic moment and created a model of a bar magnet with arrows representing the magnetic field caused by it at 7 different locations around it. I answered the 2 what-if questions and also went over possible errors and explanations for those errors. Thank you for watching.